Introduction.
Hey Sudha, look, I have made a triangle. Can you make a similar triangle? Yes, I can make, but I do not have a ruler to measure the length of its sides. Do you know, we can make it without taking its measurements. Really? Yes, our teacher has taught us many constructions. Do you want to know? Yes, please. Okay, come, I will teach you some constructions today.
Objectives. At the end of this lesson, you'll be able to divide a line segment in a given ratio, construct a triangle similar to a given triangle as per a given scale factor which may be less than 1 or greater than 1. Construct a pair of tangents from an external point to a circle. Line segment. In geometry, a line segment is a part of a line that is bounded by two endpoints and contains every point on the line between its endpoints. Example of line segments include the sides of a triangle or square. More generally, when the endpoints are both vertices of a polygon, the line segment is either an edge of that polygon if they are adjacent vertices or otherwise a diagonal. When the endpoints both lie on a curve such as a circle, a line segment is called a chord of that curve. Dividing a line segment. If we are given a line segment and we have to divide it in a ratio 6:3, we can do it by measuring the length and then marking a point on it that divides it in the given ratio. But suppose that we do not have any way of measuring it precisely. So we will use the constructions shown in the next screen to divide a line segment in a given ratio. Let's learn. Construction 1. Construction. To divide a line segment in a given ratio. Given a line segment AB, we want to divide it in the ratio m:n, where both m and n are positive integers. Let's take m as 4 and n as 2. Steps of construction. Draw any ray AX, making an acute angle with AB. Now with the help of compass, locate m plus n points, that is 6 points, A1, A2, A3, A4, A5 and A6 on AX so that AA1 is equal to A1A2 is equal to A2A3 is equal to A3A4 is equal to A4A5 is equal to A5A6. Join BA6. Now m is equal to 4, so through the point A, we will draw a line parallel to A6B by making an angle equal to angle AA6B at A4 intersecting AB at the point C. Then AC is to CB is equal to 4:2. Now let us prove mathematically how this is correct. Since A4C is parallel to A6B, therefore by the basic proportionality theorem, AA4 upon A4A6 equal to AC upon CB. Now by construction, AA4 upon A4A6 equals 4 upon 2. Therefore, AC upon CB is equal to 4 upon 2. This shows that C divides AB in the ratio 4:2. Construction of a triangle. We will now learn to construct a triangle using the construction of division of a line segment. Construction. To construct a triangle similar to a given triangle as per given scale factor. The scale factor here means the ratio of the sides of the triangle to be constructed with the corresponding sides of the given triangle. We have two different situations for this construction. In first situation, the triangle to be constructed is smaller, and in the second, the triangle is larger than the given triangle. We will solve some examples to understand this. Example. Construct a triangle ABC of sides 3 cm, 4 cm and 5 cm. Draw a triangle A-BC- similar to triangle ABC, each of whose side is 2/3 of the corresponding sides of the triangle ABC. Steps of construction. Take a line segment BC of length 4 cm, with B and C as respective centers and radii 3 cm and 5 cm. Draw two arcs intersecting each other at A. Join AB and AC. This constructs triangle ABC. Draw any ray BX making an acute angle with BC on the side opposite to the vertex A. Locate 3, the greater of 2 and 3 in 2/3, points B1, B2 and B3 on BX so that BB1 is equal to B1, B2, which equals B2, B3. Join B3, C. From B2, draw B2C' parallel to B3C by making corresponding angles equals intersecting BC in C'. Now draw a line through C' parallel to the line CA to intersect BA at A'. The triangle A'-BC' is the required triangle. Example 2. Construct a triangle similar to a given triangle ABC with its sides equal to 5/3 of the corresponding sides of the triangle ABC, that is, of scale factor 5/3. Solution. Given a triangle ABC, we are required to construct a triangle whose sides 5/3 are of the corresponding sides of triangle ABC. Steps of construction. Draw any ray BX making an acute angle with BC on the side opposite to the vertex A. Locate 5 points, the greater of 5 and 3 in 5/3, B1, B2, B3, B4 and B5 on BX so that BB1 is equal to B1, B2, which is equal to B2, B3 equals B3, B4 equals B4, B5. Join B3, the third point, 3 being smaller of 3 and 5 in 5/3 to C, and draw a line through B5 parallel to B3C, intersecting the extended line segment BC at C'. Draw a line through C' parallel to CA, intersecting the extending line segment BA at A'. Then A'-BC' is the required triangle. Tangent to a circle. We know that if a point lies inside a circle, then there cannot be a tangent to the circle through this point. If a point lies on the circle, then there is only one tangent to the circle at this point. The tangent is perpendicular to the radius through this point. Therefore, to draw a tangent at a point of a circle, we can simply draw the radius through this point and draw a line perpendicular to this radius through this point, and this will be the required tangent at that point. And if the point lies outside the circle, then there will be two tangents to the circle from this point. Construction of tangent to circle. Construction. To construct the tangents to a circle from a point outside it, we are given a circle with center O and a point S outside it. We have to construct the two tangents from S to the circle. Steps of construction. Join SO and bisect it. Let A be the midpoint of SO. Taking A as center and AO as radius, draw a circle. It will intersect the given circle at the points Q and R. Join SQ and SR. SQ and SR are the required two tangents. Let us now check how this construction provides us the required tangents. Join OQ. We can now see that SQO is an angle in the semicircle and therefore angle SQO is equal to 90 degree. Also, OQ is a radius of the given circle. Therefore, SQ has to be a tangent to the circle. Similarly, we can say that SR is also a tangent to the circle. Did you know? If the center of the circle is not given, then we can locate its center first by taking any two non-parallel chords and then finding the point of intersection of their perpendicular bisectors. That point of intersection is the center of the circle. Summary. Let us summarize what we have learned. Dividing a line segment in a given ratio. Constructing a triangle similar to a given triangle as per a given scale factor which may be less than 1 or greater than 1. Constructing the pair of tangents from an external point to a circle.